In the last few videos I've discussed arrays and variable arguments which store values of the same type. In this video I'm shifting gears to talk about multi-dimensional arrays and how Java provides support for them. I've briefly mentioned before that an array element can actually itself be an array. It's known as a nested array, or an array assigned to an outer array's element. This is how Java supports 2- and 3-dimensional arrays of varying dimensions. A 2-dimensional array can be thought of as a table or matrix of values with rows and columns. You can use an array initializer for this, which I'm showing on this slide. Notice the two sets of square brackets on the left side of the assignment in the declaration. Using this type of declaration tells Java we want a 2-dimensional array of integers. Here I show the same declaration with array initializers that mean the same thing. The first example just uses white space to make it more readable. In this example, all the nested arrays have the same length. A 2-dimensional array doesn't have to be a uniform matrix though. This means the nested arrays can be different sizes, as I show with this next initialization statement. Here we have an array with 3 elements. Each element is an array of integers, a nested array. Each nested array is a different length. If you find that confusing, don't worry, it should all make sense shortly. You can initialize a 2-dimensional array and define the size of the nested arrays as shown here. This statement says we have an array of 3 nested arrays, and each nested array will have 3 ints. The result of this initialization is shown in the table on this slide. Java knows we want a 3x3 matrix of ints, and defaults the values of the nested arrays to zeros as it would for any array. You can initialize a 2-dimensional array without specifying the size of the nested arrays. Here we're specifying only the outer array size by specifying the length only in the first set of square brackets. We've left the second set of square brackets empty. The result of this initialization is an array of 3 null elements. We are limited to assigning integer arrays to these elements, but they can be any length. We'll be looking at this in code shortly. There are a lot of ways to declare a 2-dimensional array. I'll cover the 2 most common ways here. The most common, and in my opinion, the clearest way to declare a 2-dimensional array is to stack the square brackets as shown in the first example. You can also split up the brackets as shown in the second example, and you'll likely come across this in Java code out in the wild. Let's get back to some code. I've created a new project called Multiple Arrays. I want to start with a simple 2-dimensional array in the main method. In square brackets array, 2 equals new int with 4 in square brackets, 4 in square brackets. Here, I'm using 2 sets of square brackets after the primitive type int and naming the array variable array2. This instantiates an array that has 4 elements. Each element in the outer array gets assigned a nested array with 4 elements, each an int with a default value of 0. I'll print out array2 using arrays.toString and its length. And if I run this code, you can see the length of array2 is still 4, but when I use the arrays.toString method, you can see 4 elements printed. You might remember this odd-looking printout, which is really the result of just calling the toString method on an integer array without using the arrays helper class method. Let's print each element in the array individually. I'll define a for each loop using an int array calling it outer using array2 and print outer. In this code I'm using the for each loop, but remember what our loop element is. It's an array of integers. This loops through the outer array and each element is an array of 4 integers. Let's run this to see what output is produced. I get similar output to before, but now each array is printed on its own line. If I change the code and instead of just printing each loop element, which contains an array, I'll instead print it by using the arrays.toString method and running this code. We finally get to see the values in each nested array. As you can see, each of the elements in the nested arrays are initialized with zeros. You can print all these elements out using a nested for loop. Let's do that next because you'll probably see code processing nested arrays that look similar to what I'm about to type. Loop through our outer array. Save element I of array2 to a variable called inner array. This loop should look familiar. I'm traversing the outer array using the I index. I'm looping from 0 to 1 less than the length of the array. Right now I'm not doing anything except assigning each element to a variable in the loop I called inner array. I'm using var as the type because, as I've discussed earlier in the course, Java can infer the type of our elements using a statement like this. In this case, it's an integer array. Next, I want to loop through the elements that are in each of these nested arrays. I'll start with a second for loop. This time, the for loop will be looping through all elements of inner array. And now we will print out array 2, element I, element j, and a space, and a call to println to take us to the next line. I'm looping through the inner array's elements using a nested for loop and a different loop index, j. And j starts with 0 because arrays are always indexed starting at 0. I'll print each element using the indices for the outer loop and the inner loop. Let's look at what I'm really doing here with the help of a slide. When we access a one-dimensional array element, we do it with square brackets and an index value. So this code sets the first element in the array to 50. To access elements in a two-dimensional array, we use two indices. So this code sets the first element in the first array to 50. This next code sets the second element in the second array to 10. The code on this slide is similar to the code we have used in IntelliJ using nested traditional for loops. In this case, we're not using any local variables, but accessing array elements and variables directly. This table shows the indices which are used to access the elements in the two-dimensional array in our code sample. When we loop through the outer loop, we're accessing each row of elements. I've highlighted the first row, which would be the elements accessed when I equals 0 for the outer for loop. When we loop through the inner loop, we're accessing each cell in the array. A cell in this matrix can be any type. In our code, each is an integer value, and we know they've all been initialized to 0. Now, getting back to my code, you've learned that we can use nested for loops with indices to print each of our elements. We can use for each loops as well, so let's add code that does the same thing using that approach. First, I'll comment out the traditional for loops, then I'll add some new code. For each using var outer, and we are traversing array 2. For each this time using var element and the outer array. I'll print the element and add a space after it. And I'll add a call to println to take us to the next line. I've said the enhanced for loop can take an array as the right-sided component, and here I use my two-dimensional array, array 2, which is perfectly valid. On the left side of the colon, in the parentheses of this for loop declaration, I'm setting up the element I'm looping over. In this case, it's a one-dimensional int array, and I'm going to call the local variable outer in this loop. And again, to make our jobs easier, we don't have to declare the type because Java can infer it if we use the var keyword. Next, I nest a second for each loop, which will loop through every integer in our matrix of data. I use the outer variable now as the right-sided component in the loop declaration. The for loop variable in this nested loop, which I'm calling element, is simply an int, but again, I'll just use var here. And I'm just printing each element out with a space between the elements, and in between rows, I'll add a new line. I want that after the inner loop completes, but in the outer loop. I'll run this now so we can see what happens. You can see that it gives me the same output as before, but the output is a bit easier to read. We already know we can use toString on the arrays class to print out a nicely formatted one-dimensional array. As it turns out, the arrays class provides me with another method to print multi-dimensional arrays called deep2string. Let's comment out my last for loop again, and this time just print out our array using this one method. Println arrays.deep2string passing array 2. If I run that now, the two-dimensional array is printed on a single line. Here you can see the outer square brackets, which represent the outer array, and the inner brackets each mark the inner arrays. So now let's actually assign some values to our two-dimensional array, something other than zeros. And I'll do this again with the traditional for loops because I need to use indices when assigning values. I'll uncomment the code I had, lines 17 to 23, but then comment out the two print statements. Next, I'll insert a statement in the nested for loop. Element ij of array 2 equals I times 10 in parentheses plus j plus 1 in parentheses. So what is this doing? Let's just run that code because it's easier to explain it after we see the results. Each iteration of the outer loop index gets multiplied by 10, and the inner loop index gets added to that plus 1. This was just one to show you how you can assign a different value to every element in a two-dimensional array using nested for loops. Let's end this video here. In the next video, we'll move from a two-dimensional spreadsheet example of nested arrays to a much messier but more versatile construction of nested arrays.